What's up, chemistry class? Welcome to the second half of the video. Okay, so here we are at number 12. Discuss the way in which Einstein utilized Planck's quantum concept to explain the photoelectric effect. Remember, I just talked about the photoelectric effect in the last video already, and I've talked about it for a couple of videos, okay? So, here's the deal. Einstein suggested that electromagnetic radiation has a dual wave/particle nature. So he suggested that light has both natures. It was his idea, okay? The energy of a quantum depends on the frequency of the radiation. And so, the way Einstein utilized Planck's quantum concept, he used Planck's equation that Planck came up with. In Planck's equation, it was E, energy of a quantum. In Planck's equation, it was energy of a quantum equals Planck's constant times frequency. But Einstein changed it to the energy of a photon. Energy of a photon is Planck's constant times frequency. Okay? And then only photons whose energy exceeds a threshold value will cause emission of photoelectrons, which I talked about. Remember? If the light is a certain frequency, when it hits the metal will eject photoelectrons. But if it's less than that frequency, doesn't matter how long it shines on the metal, it will not eject any photoelectrons. Okay? So Einstein used Planck's quantum concept to explain the photoelectric effect. He basically said, look, Planck, you're onto something with this, with your energy of a quantum equation. But it's not just, it's a photon, because light is basically a wave of quantum, a wave of photons, essentially, is what he was saying, okay? So the dual nature. So he said it has both natures, but your equation is right. I'm just going to change what the energy stands for. So instead of energy of a quantum, Einstein changed it to energy of a photon, okay? So that's how Einstein utilized Planck's quantum concept to explain the photoelectric effect, okay? This question, I'm sorry, I should have caught it before. I just kind of assumed every system would have good questions on there. This question didn't make any sense. So number 13, I wrote it all up here. You don't do it. I could explain why it doesn't make sense, but since you haven't, it's just going to make you more confused. So just don't do 13. Boom. Boom. Don't do 13. Doesn't make any sense, okay? The idea, like all these, it gave you like temperatures and stuff, you would have ignored those, and even if when you ignore those and you try to do it, it just doesn't make any sense, okay? So don't do 13. I'm sorry I gave that to you. That's my bad, okay? All right, last question. 14. Okay? Use figure 5 in any system, okay? So use figure 5. I didn't draw it up here just because that's a, I didn't draw it, okay? That'll take a long time. Use figure 5 as to match the number, the numbered items, that means numbered, this number's not. Numbered items with the lettered items. The numbered items may be used more than once or not at all, okay? So, we have longest wavelength, highest frequency, greatest wavelength. And we have three options: gamma ray, infrared wave, radio wave. Okay? Alright. So, what has the longest wavelength? Remember, longest wavelength is the greatest, greater frequency, shorter wavelength. Right? More often shorter wave. So this is not very frequent. Not very frequent radio waves, right? The longest wavelength is the radio wave. If you remember, way at the far end is radio waves. Okay? Radio waves are the longest wavelength. But the highest frequency, remember, gamma rays. If a gamma ray hits you, it's very high frequency, it will kill you. High frequency is more dangerous. High frequency means death with gamma rays. Gamma rays hit you, you will die. Okay? So the longest wavelength is radio waves. The highest frequency is gamma rays. And then guess what? The greatest frequency, whoever wrote these questions, if I came back and taught this class again next year, I would write some of my own questions because these questions are just garbage. Greatest frequency is also gamma ray. So it would be A is with 3, depending on how you write this, but A is with 3, B is with 1, C is with 1. So highest frequency and greatest frequency are the same thing. The gamma ray has both the highest and the greatest frequency because that's the same. It's the highest this way and it's the most frequent. So I don't really know why. They could have asked you about some other. Infrared rays are not, they're more in the middle. They're kind of by microwaves. They're not the longest wavelength and they're not the greatest frequency. So remember though, it's important to remember radio waves have the least frequency, right? They have way less frequency than gamma rays have the most frequency and the smallest wavelength. So you have more waves, right? I'll just click more waves up and down. Boom, 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 boom. Right? More waves, more dangerous, smaller frequency versus radio waves, rays with greater wavelength, right? Longest wavelength, less frequent. See? to the last frequency. Boom, in the same space, you'll have like 50 versus like 1 or 2, okay? All right, so I'm sorry the 13 didn't make any sense. And so when you finish these questions, take a photo of them and email them to me. Let me know if you have any other questions I didn't answer. I'm going to make a couple more videos. No, I'm not going to assign any more questions. I'm going to make a couple more videos, though, to try to explain the last of this lesson and how this ties into electrons and how electrons behave. Okay? So stay tuned for those later this week. But now that I've given you these, hopefully you can finish the homework. And I'm sorry 13 didn't make any sense. I should have checked on that before I assigned it. I just assumed Edit System had all questions that made sense. But I guess whoever is in charge of the program didn't pay attention to that. So, all right. Have a good rest of your week, and I'll see you later this week for some of my last videos, okay? Explaining some things. All right. Nos vemos.